Okay, we're going to look at our third function family today. This is the one that's most fresh in our mind because it's just from Unit 8 about quadratic functions. So let's just first start by reviewing some of the key features of a quadratic function. Our do now question says, what are the coordinates of the vertex and the equation of the axis of symmetry of the parabola shown in the graph below? So if we remember, the vertex is another word for the turning point. It's either a maximum or a minimum. So in this case, this point would be our vertex, and that point looks like it's at the point -2, 6. So we know that our vertex is -2, 6. We can eliminate choice 1 and choice 2. Now, when we're talking about the axis of symmetry, remember that the axis of symmetry, to be symmetrical, means to split something in two equal halves, and the axis of symmetry always goes through the vertex. So if I were to draw the axis of symmetry, it would be this blue line right here. And we know that the axis of symmetry is always an equation written in the form x equals, and in this case, our x value is at -2. So our axis of symmetry would be at x equals -2, so the do now is choice 4. So to get into transforming quadratic functions, we're going to be back in our packet, Function Families Part 1 on page 7. Just like with the last two lessons, we're going to be trying to see how do we compare a quadratic function that's been transformed to the parent function. So when we're talking about quadratic functions, our original or our parent function is going to be y equals x squared. That's our original function. And the way that we're going to transform that is by using the following parent function. Y equals a parentheses x minus h squared plus or minus k. So in these three activities here, A, B, and C, we're going to see how transforming a, h, and k affects our graph. So you'll notice in part A here, the two transformations that they were making from the original parent function is adding 2 on the end or subtracting 2 on the end. So we're changing in this first part our k value. Let's take a look at what those graphs would look like. So you'll notice on the graph here, we have our original parent function f of x in the middle. Then here, to get to g of x, we notice that the graph here moved up 2 units. So by putting this +2 on the end, that means that our graph moves up 2 units. Now comparing h of x back to that original f of x function, notice now that the graph was moved down 2 units. So we notice that just like with our exponential functions, when you put a value of k on the end, if it's positive, that moves your entire graph up. If it's negative, that moves your entire graph down. Let's look at part B. In part B here, you'll notice that we're now changing our h value because we're now putting a number inside of the parentheses. So let's take a look at what the g of x and h of x graphs look like in part B. So here are 3 functions here. Notice that we have our f of x in the middle. That's our original function right here. Now to get to g of x, you'll notice that g of x is this function over here on the right side. So the way that we move that is that we move the graph actually to the right 3 units. So you'll notice here that when we put a -3 inside the parentheses, the graph was shifted to the right. Looking at h of x, so h of x is this graph over here on the left side. If we compare that back to the original function, you see that this graph was moved to the left 2 units. So putting that +2 on the inside actually moves the entire graph to the left 2 units. So what we see here in part B is that putting an h value or a number inside the parentheses shifts our graph left or right. And a special note to make here is that it's the opposite. So when we are shifting something to the right, we'll have a minus sign inside our parentheses. When we're shifting to the left, we'll have a plus sign or a positive number inside our parentheses. And last but not least, let's take a look at part C. So in part C, we're going to change that a value, meaning that number out front. Still working with our original parent function. Let's see what happens if we put a negative out front, a 2 out front, or a 1/2 out front. So taking a look at this picture, these are what the graphs look like. Again, notice that we still have our original parent function, f of x, which is this function right in the middle up here. So looking first at negative x squared, that's this graph down here. So here's our g of x down here. So how is this transformed from that original function? You'll notice that now this means that our graph is upside down. So what we've seen here is that if our a value is a negative number, that flips or that reflects the graph under the x-axis or upside down. Let's look at our h of x function. So that's the function with a 2 out front. That's this one in the middle here. So you'll notice that our graph now is still facing up, but it's a little bit skinnier. Our graph has become more narrow. So what happens here when we put an a value of 2 out front is that our graph has been vertically stretched. So picture like I put my fingers on the end of the graph and I stretched it out. Another way of thinking about this is that the graph is narrower. It's also steeper. It rises a lot more quickly. And finally, looking at our j of x function, our j of x, again, is another upwards facing parabola, but this one looks a little bit different. This one looks like it's been more smushed or spread out. So when our a value is 1/2, the graph has been vertically compressed. And another way of saying that is that the graph is wider. So we notice that the a value can actually do 3 different things. If it's negative, that flips the graph upside down. If it's a number greater than 1, such as in this case a 2, the graph was vertically stretched or more narrow. And if our a value is a decimal between 0 and 1, our graph has been vertically compressed, more smushed, and it's a bit wider. So looking at page 8, you see that we've summarized all of these results for our third function family, the quadratic function. Again, our original parent function over here is y equals x squared, but in a more detailed form is y equals a, x minus h squared plus or minus k. Our original parent function is a parabola looking as such in this graph. The domain is all real numbers because I can put in any number for x. And our range is y is greater than or equal to 0 because our y values are either 0 or greater. So you'll notice that the 3 ways that you can transform your graph are summarized here. If you change your k value, meaning that number out front, if it's positive, that shifts your entire graph up. If it's negative, that shifts your entire graph down. The second way you can transform your quadratic functions is by changing your h value. And remember, this is when we move opposite of what you might normally think. So if we have a minus h or a negative number inside our parentheses, that shifts the graph to the right. If we have a positive sign inside the parentheses, that shifts our graph to the left. And lastly, the last way that we can change our quadratic functions is by changing our h value. And here 3 different things can happen. If we have a negative value of a, our parabola is reflected upside down, or it's reflected below the x-axis. If our a value is greater than 1, such as 2 or 3 or 4, our graph becomes more narrow or it's vertically stretched. And if our a value is between 0 and 1, meaning it's a small decimal, our graph has been vertically compressed and the graph looks a little bit wider. So let's take a look at our quadratic functions in this guided practice right here. We're going to compare this to our original function, f of x equals x squared, and now we're looking at this function, k of x, right here. So what I notice in our k of x function is that our a value is -3, our b value is +1, and our k value here is -2. So our first question says, what transformations happened here in k of x? So starting with our a value, 2 things happened here. Because our a value is negative, our graph is reflected upside down. Now the parabola faces upside down. The other thing that happened because the a value was 3 is that the graph has been vertically stretched, or the graph is more narrow. So two things happened because of that -3. The first is that it was reflected upside down. The second is that it was stretched vertically or became more narrow. Because our b value was changed to a +1 here, that means that our graph was moved to the left 1 unit. And finally, because our k value on the end there was a -2, that means that the whole graph was moved down 2 units. So there were 4 different transformations that happened in our k of x function. Let's take a look at the second question here. It says, how is the vertex of k of x related to the vertex of f of x? Well, if we think about our original f of x function, x squared, the original vertex on that would be at 0, 0. If you were to go into a graphing calculator and graph k of x, the vertex of k of x would be located at -1, -2. If you remember our lesson on vertex back in Unit 8, we learned that you can find it by finding the opposite of the h value, the k value. So how are those two vertex related? From our original function 0, 0, into the new vertex of -1, -2, the vertex was moved left 1 unit, and it was also moved down 2 units. So you'll notice that the left or right and up and down shifts also move the vertex. So in this case, our vertex was moved left 1 unit and down 2 units. Let's go ahead and take a look at our checkpoint question. There are 3 different problems here. It says, describe how each function has been transformed from the parent function f of x equals x squared. So take a moment to try these 3 problems. There may be more than one transformation for each part, and then come back to check your work. So looking at part A here, because we put this -3 on the end, that means that our k value was -3. We know from our notes that if our k value is negative, that shifts the entire graph down. So for part A, you should have said that the graph was moved down 3 units. For part B, we'll notice that they put a -3 inside the parentheses, so that means that our h is a -3. We know that a number inside the parentheses moves our graph left or right, and it moves opposite. So because we had a -3 here, our graph was moved to the right 3 units. So for part B, you should have said to the right 3 units. And finally, for part C, we see that now they put an a value out front of -1/3. And actually, this means that 2 different things happened. Because our a value is negative, that means that our graph is upside down. You could also say instead that it's been reflected over the x-axis. That's another way of saying upside down. The second thing that happened, because the a value became a 1/3 or a decimal, is that the graph has been vertically compressed. And another way of saying that is that it is wider. So for part C, you should have identified 2 different transformations. First, that it was upside down or reflected, and the second, that it has been vertically compressed or wider. For our independent practice, let's take a look here. If you had none or just one of those 3 transformations identified correctly, please start with red. If you only answered 2 parts correctly, or maybe you forgot one of those 2 transformations for the last question, please try the yellow questions. And if you were able to find all of those 4 transformations, please try the green problems here. You'll also notice that now you should be able to answer 5 of the questions from your Regents packet, so please make sure that you give those a try. Please pause the video, go try these problems, and then come back to check your work. Okay, let's check our work for the independent practice. Here's numbers 1 and 2 on page 8. Here's numbers 3 through 6 on page 9. Here's numbers 7 and 8 on page 9. Here's numbers 9 and 10 on page 10. Here's numbers 11 and 12 on page 10. Here's 13, 14, and 15 on page 11. And finally, here's 16 and 17 from page 11. You'll notice that a lot of these problems came from old Regents exams. They like to ask about transforming quadratic functions. That's a popular question on the Regents. If you have any questions about any of these problems, please let us know. Otherwise, you are now able to answer number 3 on the exit ticket, which is the last question. Go ahead and try that exit ticket question, and then you should be able to turn in that exit ticket. And also on homework 9.1, you are now able to answer numbers 3, 4, and 5. So you should also be done with homework 9.1 as well.